Good morning, students. I hope you are doing great. Okay, so today I would like to continue with the limit for ovality, right? It is the previous, just a conjunction with the previous topic, which we had covered in under the schedule for fit and clearance. So, limit of ovality actually it is something which measure the circular shape of the hole as well as for the shaft. So this is the it comes under the limit of ovality, right? So here we discuss about the both cases means for the hole as well as for the shaft. Uh, this usually occur as a result of the surface wearing through the friction or linear movement. The ovality can apply equally for the holes and shaft, right? So it's near about same for both for the holes and for the shaft. And if we are doing or we are going to measure the hole test, right? So then we have some couple of instruments like go and no go gauges, internal micrometer, and the caliper. So we are quite familiar with the uses of the micrometer and the caliper, but for the go and no go cases, I have also shared with one video which will help you with regarding the uses of the go and no go gauges, right? So actually, it looks like this. So um, these ends are having some different diameter and we will pass it through a hole. If it is going easily, then that is the go, and if it is not going easily, then it is no go, right? So which is just it is just passes, and above that, if it is not get passes, so which is passes easily, then we consider its diameter, which is indicated over the tool, right? So it's the quick and accurate method to find out the internal diameter of any hole. Or the same way for the shaft, we can also test with the use of the snap gauges, with the use of the external caliper and the micrometer. So external caliper or outside caliper are same, and the micrometer for using of this thing for the tube, and also we can check its validity with the help of the vernier caliper also. So there is no need to be get confusion, because vernier calipers also can measure the external diameters, right? So for any shaft we have to concentrate over the external diameter, right? And the uses of snap gauge, again I have given some couple of video, so kindly go through the scene, and then you will get a lot of interest definitely. It is important to test the variety of shaft before the testing it for bow. So bow is what? It's something about the bending of the shaft. So there is a procedure we have to follow, in which the ovality should be tested first, then the bow. Otherwise, there is a chances for wrong readings, or we can say that suspected readings, which may get come. And the bow in a shaft can be determined by utilization of V block and the DTI. So DTI also known as, the full form is dial test indicator, somewhere it's also known as dial indicator or dial gauge. So both are same. Alright, so now concentrate on the holes. So the dashed line which you can see, it is the initial, or it is the should be value, right? It's an idle shape. For a hole, it's the idle shape, and this reading generally we get when the aircraft is new or that component is new. where the hole is going to be made. But after certain operation, due to the high rotation, due to the high load, and another factor of forces acts on the system, so it starts to deform. There, the deformation of the shape has happened. The line which you can see here in a dark line, right? This is the at present condition. The dashed line when the component was new, right? And this is at present condition. And now the gap between the idle and this is called wear, right? So now the question may arise, I'm going to uh, measure the things now. So how can I get the dashes value? Because dashes value was around 5 or 10 years back on the aircraft. So how can we get that? So for that thing we have to refer this thing, your manual. So there is a weird limit chart. So we have to follow the same. In the same way, the shaft is also get measured. So the dashes line, which is going up, is the normal condition, but the dark line it is today's condition. So again, the difference between the normal and today's condition or the abnormal condition is again it's weird, right? So there, these are the couple of instruments which we use to check the ovality of the hole, right? So we all are aware about these instruments. So in micrometer we have the discuss. It was the external, but this is the internal micrometer. The concept is same, right? The procedure for reading is also same, right? And this is the tools which we use for testing of the uh, shaft ovality, right? So we all are aware with these two. This is something new for you, so I have posted one of the videos so which will help you with. Now let's discuss about the limit of bow. So what is the bow? Bow is nothing, it's a bending, right? So we must have to understand that if the central line of any rod or a square shape is going straight, so that means they are uh, normalized, right? And if it is having a curve, the center line having a curve, so that means the thing has been, you can say, it's bended, right? So there is a bending in the shaft. When dealing with the shaft and tube, so here the tube and shaft there is a difference. Both looks like same, but tube are generally we consider the hollow cylinder, and shaft we consider as a solid cylinder, right? So when dealing with the shaft and tube, it is vital that not only are the end square with each other, but the center line of the complete shaft or tube is straight. So we have to check for two things. One is its end squares, for its end square. If there is no change in the shape, so we can say that it's okay in condition. But also we have to check the center line condition. If the center line of the shaft is not straight, then the item is bowed. When the shaft or tube is rotating, especially at a high speed in a bow state, there is a risk of vibration, which can lead of the mechanical failure, the losing of fastener, or most critical of all cases, uh, that can also go with the body condition. Right? So it's our responsibility to check for all the shaft or tube as per described maintenance procedure or the checklist that it should be straight as possible, because if something is rotating, but it is not in the straight condition, so obviously it may lead for the heavy vibration. All the cylinder item, both tubular and solid, can be given a limit of amount of bow per meter. So again, there is a bow limit chart which you will refer with the maintenance manual or the structure repair manual where the limit and bow chart is given. You have to check it that whether the uh, bow is under the prescribed limit or not. This ensures that within the limit of production, the dry shaft are effectively straight given the least possible vibration. So again the same thing. So the limit should be the condition should be under the limit, right? And if it is going beyond the limit, you have to change it or need to take the prescribed maintenance procedure. On limit of twist. So it's the last topic for the topic which we are covering. There are the four things under uh, the condition of testing, uh, in which one was the limit of wear, then limit of ovality, limit of bow, and limit of twist. Right. So twist is what? So suppose something is rotating, so one force will act in the clockwise and second will counterclockwise, right? Due, due to this, there is a chances of the twist. But if the twist is under the limit, means the elastic limit, so after removing the load, the twist effect will be disappear. But if it is beyond the limit, beyond the elastic limit actually, so the twist will be uh, remain there. So twist is a result of applied the torsion or the circular or square sectional shaft. If the twist disappear as a result of the removing the force, then the shaft will have been loaded below its elastic limit, right? So if the application of load is under the elastic limit, so when the force is removing, then the twist will disappear, it will come straight. But if the shaft is twisted after the removal of the load, then it can be loaded above its elastic limit. So this is the main concern area. So if the shaft has a square section, it can be checked for twist on the surface table using a DTI, the dial test indicator or dial indicator, mounted on a surface gauge. So application of DTI will have been shown in the video, so I will also share with you, right, along with this study material. It is possible to measure the amount of twist to which a shaft is subjected while the operation of the rotation by the use of the strain gauge. So the concept for checking the twist is also um, we can measure the strain, uh, so the strain limit of the shaft with the help of the strain gauge, right? So both of the videos have been shared with you, so don't worry, right? So the designer of the aircraft or equipment will set all limits with regards to the distortion of parts and set them down to the 11 manual. The method used to measure the distortion will either the standard procedure such as using of the DTI and surface table, or it may have some special procedure and which will definitely be given in the manual. So this is how it looks like, the strain gauge and the dial test indicator. Will show you the video, will share with you. So if you have any doubt for today's session, we can also clear all of these in our doubt session, which is scheduled at 3 p.m. So for that timing, please be in touch with your study, continue do your study, and please stay safe at your home. Thank you so much.